Assalamu alaikum. Welcome to Dr. Abrar YouTube channel, and today my lecture is in continuation of my previous topic, that is the periodic table. In today's lecture I will specially explain that why when we move down the group in the periodic table in a group, when we move down the group, so why in metals the reactivity increases, while in the non-metals when we move down the group, so the reactivity decreases. I will explain the scientific reason behind this phenomena. So stay with us, and my request is to subscribe my channel and share it with others. So let's start. So as I mentioned in the previous program that the elements in the periodic table, they are arranged according to the proton number or atomic number. So like proton number 1 hydrogen, proton number 2 or atomic number 2 helium, number 3 lithium, then 4 beryllium, 5 boron, 6 carbon, 7 nitrogen, 8 oxygen, 9 fluorine, 10 neon, 11 sodium, and so on. So the elements are arranged according to the proton number. So there are horizontal rows in the periodic table and there are vertical columns in the periodic table. The horizontal rows, they are called periods, and the vertical columns, they are called groups. In the periods, the elements are arranged according to the number of shells, and in the groups the elements are arranged according to the number of valence electrons. Now suppose period number 1, in period number 1 those elements are placed which have only one shell, and they are hydrogen and helium. We can see clearly in this diagram that in the horizontal row in period number 1 hydrogen has only one shell and helium is also having one shell. So that's why hydrogen and helium are included in period number 1. While in period number 2 lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon are there. Why these elements are placed in period number 2? The reason is that all of these are having two shells in total. So that's why we can see here in the diagram all of them are having two shells. Let's take the example of lithium. Its proton number is 3, and it means that it has 3 protons and 3 electrons. And what is the electronic configuration, electronic arrangement of these electrons? So that these 3 electrons, how they will be arranged, that in the first shell there will be 2 electrons and the second shell 1 electron. This is about lithium. Now come to beryllium, as it has total 4 electrons. So first shell 2, second shell 2. Then boron, proton number, atomic number is 5. It means it has 5 electrons, 2 and 3. In first shell 2, in second shell 3 electrons. 6 electrons in carbon, 2, 4. 7 electrons in nitrogen, 2, 5. 8 electrons, 2, 6. 7 electrons in fluorine, 2, 7, and 8 electrons in neon, 2 and 8. As we are moving down the as we are moving from left to right, so the electrons are, the shells are being filled with electrons, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, and 2, 8. It means that we are moving from metallic character towards the non-metallic character in a period. When we move from left to right in the period, so we move from metallic character towards the non-metallic character, because this is established that metals lose the electron they have 1 electron or 2 electron or 3 electrons in the outermost shell. That's why they lose 1 or 2 or 3 electrons. But the non-metals have 6 electrons or 7 electrons or like 5 electrons or 6 electrons or 7 electrons or 8 electrons. So that's why they are non-metals. So now they gain the electron. So metals, by losing electron, they form positive ions, and the non-metals, by gaining electron, they form negative ions. Why the metals they form positive ions, cations? Because when they lose the electron, so the proton gets in excess and they get positive charge, and the non-metals, when they gain electron, so because of the one additional negative electron, they get -1 charge. Now I am going to explain the most important part of my lecture, and this question arises in most of the mind of the most of the students. So that is that why when we are moving down the group in metals, so reactivity increases, but why when we are moving down the group in non-metals, so the reactivity decreases? What is the reason behind it? So let me explain. Remember that when we are moving down the group in any group in vertical groups are the vertical columns. Let's take the example of group 7. So here the group 7, the first member is fluorine. How many orbits we can see here? 2. And how many orbits in chlorine? 3 orbits. How many orbits are there in bromine? 4 orbits. How many orbits will be there in iodine? 6 orbits. And then astatine will be having 7 orbits as we are moving down the group. So the orbits, number of shells, number of orbits are being added, and because of the addition of the orbits, the atomic size, the atomic radius increases down the group. Either it is in metals or it is in non-metals. The phenomena is same. As we are moving down the group, so the number of due to the addition of the number of orbits, the atomic size and the atomic radius increases down the group. Keep in mind this thing. Now the phenomena is same, that as we are moving down the group, so the atomic radius is increasing. But in metals, when we are moving down the group, so remember that metals have to lose the electron. When the shells are being added, so the atomic radius is increasing, so it becomes difficult for this central nucleus to hold the outermost valence electron because of the too much increased atomic radius. So the charge, the attraction of the nucleus towards the outermost electron, it becomes weaker, it decreases, and it becomes, now the impact on the metal is that it becomes easy for the outermost electron, because of the bigger size of the metal, because of when there are too much orbits, when there are too much shells in the metal, so it becomes easy for the outermost electron to escape and to lose. So that's why as we move down the group, so the metals become more and more reactive, because it becomes easy for the outermost electron to escape, to lose. This is the reason. While we are moving down the group in non-metals, the phenomena is same, that the atomic radius is increasing because of the addition of the orbits, but the impact is different, because we know that the non-metals, they gain the electron, they achieve the electron, and then they get negative charge. So when they have to achieve the electron, so because of the increase in the atomic radius, the charge, the attraction, the force of attraction between the nucleus and the outermost electron already decreases because of the too much orbits, because of the increase of the atomic radius. The force of attraction gets weakened, and Another thing is because of the shielding effect, because of the electron repulsion. So it becomes very difficult for this bromine or for the iodine or for the astatine as the atomic size is increasing. So it becomes difficult for the non-metal to gain, to receive another foreign electron, another electron from another atom. However, in fluorine, because of the smaller size of the atom, it is easy for the fluorine to receive an outermost electron, because its size is smaller and the force of attraction between the nucleus and the outermost electron is stronger. So this is the reason that when we are moving down the group, so the more, let us say, the cesium or francium will be most reactive, but in case of non-metals, fluorine will be most reactive, and the most stable bond formed will be between cesium and fluorine, cesium fluoride, or we can say francium and fluorine, francium fluoride. However, we do not consider francium because it is radioactive. But I repeat that here in metals, as we are moving down the group, so the cesium will be most reactive, but in non-metal, fluorine will be most reactive. So this is the main thing. So I hope you understood my lecture. Thank you very much.